Howdy, howdy. This is Stephen Brown presenting my EECS 382 project for Google App Engine. So basically what I did in my project was I took my EECS 285 project, which is right here, and I attached on a networking component. The goals of this were to allow two players. There's two players. Unfortunately, I only have one computer, so, I have two players play against each other, exchange salvos, information about the game, what their move is, things of that nature, and also to maintain a global list of how many games are currently ongoing, and list of completed games and stuff, things of that nature. This is the home page of it. As you can see, there isn't very much. Most of the app is basically what's behind the 285 application. Like I said, the only thing really is here is there's the game list of things in progress, completed games. I'll come back to that later though. So, the way it works is the first player will join a game. Let's name him Pikachu. So Pikachu joins a game. It creates a game lobby. The game lobby is in the game list. You see Pikachu versus unknown. It's waiting players to join. So Pikachu is checking back every now and then, waiting for another player to join. And so let's create the other player. Name him Charizard. And this player is created, and Pikachu finds out, oh, there's someone else that joined my game, and Charizard immediately joins into that game. And each player receives a request that says set up ships. Okay, let's say Charizard finishes last here. So Pikachu now becomes the master player because Pikachu is the first one in the game. It's a master servant configuration. So Pikachu is actually the one running the game since App Engine's request handlers are actually stateless. And so Pikachu has to decide, okay, it's my move, okay, there was a hit, now it's still my move, versus, okay, Charizard here is handling requests. So Pikachu will post a command, Charizard will have to respond. That's basically how it works. So Pikachu's waiting for Charizard to finish. So Charizard finishes his placements, and he sends a done command over the network by posting a done instruction to the data store. Pikachu retrieves that because that's what Pikachu is polling for. And Pikachu, it's his turn to open fire. So Pikachu's going to miss. There's actually a lot that goes on in a single shot. So Pikachu posts first he posts a receive fire command to Charizard. That gives Charizard a heads up saying, hey, there's a salvo here, this is my move. Tell me if it's a hit or not. Charizard responds saying, nope, that missed my ships, it's all good. He sends a salvo result, which is basically a vector of these coordinates, saying they're all misses. And Pikachu receives them in turn. Pikachu realizes it's a miss, so he's going to end his turn. And when he ends his turn, there's a update that goes to the game lobby. So if I go back to here, this was our game lobby before. So now it's Pikachu versus Charizard. Yeah, that's correct. 0 hits apiece. So it's Charizard's turn to move. Charizard's going to post a salvo, and Pikachu was expecting it because remember, Pikachu is the master controller. So Pikachu receives a salvo, sends a receive fire command to Charizard, and Charizard has to handle it and say, oh, I got hit. So it's still Charizard's turn. The master controller, Pikachu told Charizard that. So Charizard continues his move. Apparently, oh, okay. There's a little lag going here, but anyways, Charizard misses. It's the end of his turn. It's Pikachu's time to open fire. If I go back here, you can see that it is up to date with 8 hits, and Pikachu is trailing. So if Pikachu were to hit, there's 2 hits. This is not updated right away. The reason for that is I wanted to minimize the time between shots. I want a better response time. So that it's only updated eventually, meaning at the end of a turn. So Pikachu fires, it's the end of his turn, and there you go. He's still trailing though. So that's basically how it works. I actually have another game running. Let's see, yeah, here's the other game. This was Thomas versus Russell. Thomas is winning. It's a close game. So looks like it's this guy's turn. So he's going to post a salvo and get a salvo result and all that stuff. and that should update. Oh wait, was that a hit? Oh, yeah, it was. Okay. That updates. Oh, it was a miss. I'm sorry. So that's why you don't see anything. Anyways, where were we? So I want to just illustrate wind conditions. This is basically a wind condition because it's basically the wind button. That was a part of our EECS 382.mp4 project, and there's a little animation going on. Oh yeah, it's his turn. Pikachu lost. Looks like Charizard won. The notification got behind here or something. But regardless, the game is updated. Game is marked as completed. This one's still in progress, and you can see there's completed games, and these were actually disconnected games. So like a player joined the game, then disconnected. It happens quite often. So what I did to address that was I inserted a scheduled task. Since I don't want to wait around here half an hour, I'm going to run it. But basically what it'll do is it'll say, it'll look at all the games in progress, and if in another half an hour these games are still here, it'll clean it up. So I don't think it's run since we started this, so I'm going to tell it to run. It runs. Looks like, yes, it didn't clean it up, and for good reason, because it was marking the first ones as, here's what is currently on the list. So I run it again, and it cleans up all the in progresses. Those are assumed to be players that have disconnected, since if they haven't run in over half an hour, chances are they've been a disconnect. Another optimization you see here is I have a from the memcache. This is retrieved from the data store only sometimes, because I continually am updating the memcache every time I update a game lobby. So anytime a hit or a miss is updated here, it spins off a task to update the memcache as well. This was done because I wanted to keep the response time up for the actual game, but I still wanted the memcache update. So I just put it on the task queue, and so it's deferred till later, and the response time for a client is maintained, and it allows this page to be loaded fairly quickly. And one other thing I should mention, finally, is I've said that there's some polling going on, like how Charizard was waiting for a salvo and Pikachu was waiting for instruction, or things of that nature. I have it poll every 100 milliseconds. That was to make it so it doesn't appear laggy to the user. But since a lot of times users tend to either click right away, or they're getting a sandwich or something and taking forever, every 10 poll attempts, that wait time is doubled. And so first it's 100 milliseconds, and 200 and 400. And pretty soon, so if you have some games that are, it's just open, eventually they're going to free up whatever resources they're using, and they won't be constantly making requests. So that was one optimization. So anyways, that is my app, and thanks for listening.